Well, today I want to talk data mining, which is what I'm really interested in. And I want to explain a little bit about the inner workings of data mining, a little bit of the sort of terms that you might have heard when you read your first lecture or the first book. I want to talk about supervised learning, unsupervised learning, what exactly are these things? And then I want to get on to something new, semi-supervised learning, and also what's the research at the moment in this area. It's called machine learning. That's the sort of phrase. So applied artificial intelligence, machine learning. If we get our data, we want to mine the data, and broadly there's kind of two categories of methods how this works. So if I could pull out my prop, I've carefully prepared. Here are some items of data that I have brought along. The first method maybe that I should explain is unsupervised learning, because it's perhaps the easier way. It's called unsupervised learning because we don't have any examples that are labeled. So it's unlabeled learning. Yeah, I guess the idea is a supervisor knows the answer and we don't have anybody who knows the answer. So we get the data to begin with and we don't really know anything about it. We know obviously the attributes, we know the values, but we don't know what categories are they, let's say. That's a problem. So unsupervised learning very often is the sorting of the data. So you get your first data item and you put it somewhere, and then comes another data item and you basically go, let's do colors. Is this similar or is it different? And no, this is quite different, so we put it there. And then comes another data item. Oh, is this similar or is it different? Oh, it's a little bit similar to the yellow one, so we put it a bit closer to the yellow one. And then comes another data item, and oh, this is obviously quite similar to the yellow one, so we put it closer to here. And then so over time we get all these data items in, and they might end up a bit like something, maybe a bit like that. So what have I done? I've done a sorting of the data, and the approach I've done is something based on similarity measures. These unsupervised methods, they always use a similarity measure. In this case, I've done kind of by color. The other way these methods usually work is they actually start out by saying, well, how many groups would you like your data to be in? How many clusters would you like to be in? So let's say you want them in 3 clusters. Well, then maybe a solution might look like this. It's clustered by the color, 3 clusters. If there would have been 4 clusters, maybe the solution would have looked like this. And if there was maybe 2 clusters, it might have even looked like this. So you might ask, okay, so what's the data mining about this sorting of the data? Well, once we sorted the data in this way, we can of course have a look at, well, so what's ended up together? Maybe these things have ended up together, and maybe now we can say, oh, this is the light colors and this is the dark colors, and we suddenly have 2 groups. I mean, you wouldn't normally sort color cubes. You would say sometimes sort patients, and are they really ill or are they very ill, and you know, that sort of thing, and we could sort it by this. Now, most of the unsupervised methods work exactly like I described, so they work by sorting it. The difference is how they measure the difference between things. So is it a statistical similarity? Is it a algebraic similarity? Is it a geometric measure? You can imagine there's so many ways you can measure the difference between things. Unsupervised learning is sort of quite a simple way of doing it. I mean, it's quite quick, the algorithms, but it's not as powerful as other methods. What's the problem with it? Well, one of the problems with it is actually quite straightforward. Let's say we end up with this solution. Well, is this a good solution or it's not a good solution? It's actually really hard. It's really hard to evaluate because we obviously don't know about the data. We don't know. So we're looking at it going, well, it looks okay, but maybe not. And then very often what happens actually is if you look at the data from one way, it looks like a good solution. But now, if I do my reveal, we sort of turn the data a bit and, you know, suddenly we have another angle on the data and like, actually now it's a mess. They're not really sorted very well anymore, are they? That's often what happens in unsupervised learning. We sort them in one way and they look quite good, but then we look at the data differently and actually this hasn't quite worked and it's not so great. The other downside with unsupervised learning is the algorithms really only work when you tell them how many groups you want the data to be in. 2 groups, 3 groups, 4 groups. Now for some problems you might know this. Maybe you have, like I say, ill patients and healthy patients, then you know there is 2 groups. But very often actually, how many groups you have is the whole question. So you can't really use these methods that well. If you want to know some technical terms, k-means, for example, is a classic unsupervised method that's very popular. So if you can look that one up, then you'll learn a bit more about it. Now, second way of doing learning would be the supervised way. We said unsupervised, there must be a supervised way. And here, the difference is that you have some data which has some answers attached to it already. So you can learn from this data, really learn from it. And the classic way of doing it is the well-known neural networks. It's one of the best known ones. How does that work? Okay, well, so have some data again. And this time, let's say we want to do something a bit different. We want to just sort them in light colors and dark colors, for example. And what happens is I get my data in and already somebody has labeled the data for me that said, these are light colors and these are dark colors. So we already know the answer for this data. We don't know it for some other data, but we know it for this. This is our training data. And now I'm going to do learning in my neural network. The first data item comes in, it goes here. The next data item comes in and it goes here. And I keep doing this and maybe I end up with something that looks like this. And now, of course, now I can assess the quality of the solution because I can go, well, algorithm, you've done okay, but you haven't done it really well because these two should be over there, this one should really be there. Fix the function a bit and do it again. Okay, back. We might end up like this. It's like, okay, that was better, but you still got one wrong. Fix the function again and do it again. So this is called backpropagation neural network. I'm going to do this again, and of course, if you do this long enough, eventually the algorithm will learn the perfect function how to sort things. And then the idea is a new data item comes along, and it will go to the same function, and because the function is now perfect, it will end up exactly in the right place. No problem. It comes in, comes in, no problem. So it's supervised because we have labels, and because with labels we can assess the quality. And again, neural networks is the classic way of doing this. And in general, supervised learning is very powerful because as long as we have enough data with enough labels, we can always learn the function and then it should work really well. But, well, there wouldn't be research if we were finished with it. So there's obviously a problem with this as well. The problem with this is you can lead to overfitting. What does overfitting mean? It means like tight jeans, you know? No, not that. It means that you have too much emphasis on getting the function right. You make it too right. So the function is absolutely perfect. In fact, it's so perfect, it's brittle. It's just not good anymore. So what happens is a new data item comes along, one that you've not seen before, like that one. And the unsupervised method wouldn't have a problem with this because it just goes by similarity and it will go, oh, it's kind of a light color, it'll probably end up here. But the supervised method has never seen this color before and the function goes like, what do I do with this? And it breaks. Or it puts it just in a random place, like maybe here. So supervised learning is really good, but if you overdo it, then you overfit it, and the problem is then you actually make the system worse again, you make it brittle. The other downside of supervised learning is you must actually have enough data with labels, which for some problems you have, it's fine, but for some problems you don't really have it. So let's talk about a practical problem that I was working on. So I was working with doctors in hospital, clinicians who look after colon cancer patients, and over many years they collected data of about 500 patients, sort of classic medical data. So we've got age, we've got medical history, we've got genetic values, blood values, and so on and so on and so on. And they get diagnosed in different categories of cancer, some more serious, some less serious. And the doctors wanted some help with this categorization. The most serious cases and the least serious cases, they're quite clear. But there's just this whole group in the middle, and they wanted to make sure, can we split them a bit better? And so we were working on this with them. And so this is a classic problem. And in that case, there was 500 patients that were already categorized as in what category of illness they were in. So actually, a supervised approach was very good because we could learn from those 500 and build up a picture. And as long as we're careful and not overdo it, that'd be fine. But then what actually happened, and this leads me on to what the research is at the moment, what happened is not for all the 500 patients did they have all the labels, because some of the technology has been changing over the years. So there's more modern things now that I didn't have 10 years ago. So actually for the last 50 patients, they had some additional labels that I didn't have for all the others. And so we were talking about what to do with this. And there's a method called semi-supervised learning, which is kind of what the research is on. It's kind of what, why can't we take the best of both worlds and maybe combine this a bit? So what if you've got a few labels? It's not enough to learn perfectly, but maybe we can do something. So what we've done is a semi-supervised method, and it's kind of a mixture of the two. You get your data, and let's just say we want to split them in light and dark colors, which is basically our more serious patients and our less serious patients. And you might end up sorting the data, something like that. Because it's an unsupervised approach, first of all, we don't know exactly how good this is. But then, for some of the data items, we have a label, and we can look up what's the number on them. And because for some of we have a label now, we can say, okay, all the ones with the same label or with a similar label, are they in the same group? So suddenly we can assess the quality of this. So we don't have a label for all of these, but we have a label for some of them. Are they in the same group? Yes. And then the same labels are in the same group. Yeah, that looks like a good solution. Semi-supervised learning is probably the future because as data sets get bigger and bigger and bigger, you don't have labels anymore for everything because nobody has time to label everything. And computers can't really label things very well. So you'll have the experts labeling a few things. And semi-supervised learning will be where this is going. But the next step really would be to have it interactive. That would be even better. So that's kind of what we're working on right now. It's called the man-in-the-loop or the human-in-the-loop learning, where you maybe have no labels at all, or maybe just very few, and then you do some sorting of the data, and then we ask the expert, well, you know, has the sorting gone well? Has it not gone well? What about this one item? What would be the label you would give it? And it's sort of a bit interactive. And I think that'll be much better, because then you can, you know, do this more in real time, and you can actually also, the latest developments can come in, tacit knowledge that you might not even have in the data.
So that's like spot checking it?
Yeah, exactly. It's like spot checking it, but then putting that knowledge back into the algorithm so the algorithm can learn from it again and to sort of reinforce it a bit.
So that's a single card that's basically controlling the robot?
Well, it's 864 processors, which is more than a robot will usually get. Where are we going now? I'll show you the big machine. That's